Hello, hello, hello. Good evening, guys. Sikasote, Sikasote, can you please kind mute your mic? Okay. Good evening, guys. I am fine. How are you? Okay, so we are already behind time. Okay, so we are already behind time. My name is Harvison. So I'll be taking you in biology. So before we start, let me find out like how far have you gone in biology, like which topics have you covered, then also the coverage for the test, because I've been told that you'll be writing test one soon. I don't know when. So which topics have you covered this far, then also the coverage for the test, if at all you've been told already up to this point. Okay, okay, so from the first topic up to enzyme or proteins. Okay, when are you writing biology, guys? Can you please kindly mute your mics? Okay, 90. All right. Okay, so what we are going to do here is, I have a paper here. I think it's for 2019. It has a lot of questions on the topics that we have covered. So it's the paper I want us to look into. So let's be interactive, guys. Where you are not clear, feel free to ask. Then I'll be able to clarify. When you have any question, just feel free to ask. This is why we are here. Okay. Yeah. So this is Daploid. I'm sure most of you have this document. So it's 2019. Is the paper I'm looking for. Okay, so this one. So guys, because I know that you have been studying and you do have this document. Okay. All right. So I think we are ready to go. So this paper was a final exam, which was written in 2019, of course, from the University of Zambia. So it was BAO 1401, because I'm sure you know, now it's called BAO 1400, but back then there used to be BAO 1401 as well as BAO 1412, but now it's combined. So BAO 1401, this in short, it was covering semester one work. So the topics that you're going to find in this whole paper is those topics which are in semester one, as you see the questions. So we have cells and biomolecules. I'm sure you know by now how biology is marked. There's negative marking. If you are not sure of the correct option to the particular question, you better just put option 6, which is, I don't know, which will award you a 0 rather than negative. Because when you get anything wrong, it will attract a negative mark, negative 1. Whereas if you get it correct, you have a 4. If you put option 6, which is I don't know, you get a 0. So, okay. So I think we can start. So I think the topic 1 is on, what do you call this topic, which deals with atoms? Yeah. So let's start. Now I was thinking, okay, let's see how far we can go. So question 1 here, it reads, identify the false statement. So which of the following statement is false? Option 1 is saying the 3s orbital is the lowest energy level, energy orbital in the similar energy shell. How true is that statement? Then 2 is saying the 2p orbitals is higher in energy than the 2s orbital. 3 is saying there are 3 2p orbitals in the second shell. 4 is saying there are 3 3s orbitals in the third energy shell. 5 is saying the 1s orbital does not belong to the second shell. So which of these options from 1 up to 5 is a false statement, meaning that 4 of them are correct? So we are looking for the false statement. So which one do you think is the false statement with regard to atomic orbitals? What do you suggest? Okay, so let's start with option 1. So option 1 is saying the 3s orbital is the lowest energy orbital in the similar energy shell. True or false? Yeah, this is true. Unless if you need an explanation, you can ask, then I'll explain. Option 2 is saying the 2p orbital is higher in energy than the 2s orbital. True or false? The 2p orbital. So please, if you unmute your... Yes, go ahead. Mm-hmm. Yes. Mm-hmm. Yes. Yeah, that's true. Then 3 is saying there are 3 2p orbitals in the second shell. True or false? There are 3 2p orbitals in the second shell. How true is option 3? Let's be fast, guys, so that at least we can cover a number of questions. Okay, so 3 is a true statement. 4, there are 3 3s orbitals in the third energy shell. True or false? False. How many are saying it's false? Option 4, which is saying there are 3 3s orbitals in the third energy shell. Yes, it's... Yeah. Then 5, there the 1s orbital does not belong to the second shell. True, right? The number in front indicates the energy shell in which you are in. So if there's 1s meaning that you are in the first energy, or you are in the first shell. 3s meaning that you are in the third shell. Do you need an explanation on this? On this whole thing? Anyone who is behind? The correct answer here is option 4, by the way. Option 3, which is saying there are 3 2p orbitals in the second energy shell. So let's do this. Okay, so guys, you know that the ground state of atomic orbitals of atoms, you are going to have 1s, then you have 2s. What comes next is 2p, right? Then you are going to have 3s, then 3p, then there comes 3d. Then you have 4s, 4p, 4d, then 4, there will be an f. Let me end there. So this is the first energy shell, right? By the way, how many orbitals does maximum number of orbitals does the s orbital has? Yes, it only has one orbital, and an orbital can occupy with a maximum of how many electrons? 2 electrons, yes. So s orbital can only occupy 2 electrons. What about the p orbital? Yes, 6 electrons. How many orbitals does it have? Yes. So let me have the energy levels here. So as you go like this, the energy is what? Is increasing. So we are going to have the first shell here, 1s. Here we are only going to have how many electrons? We have 2. So that will be here. So the 1s will be here. Then we are going to have 2s. So 2s is a bit lower than what? Than the 2p. So 2s. Then 2p has got p has got how many orbitals? It has got 3. So we have 1, 2, 3. Then we'll move on to 3s. So we're going to have 3s there. Then 3p. So 3p will be a bit higher. 1, 2, 3. Then you have 3d. So let me end there. So what we have here, this is 1s. 1s. Then this is let me. So we have 1s. This is 2s. These 3, all of them are what? 2p. Then this will be 3s. This will be 3p, like that. So if we are to go back now, this arrow is showing us this is energy. Okay? So you are going to have a nucleus. The 1s is the energy level which is closer to the nucleus. So the closer the energy level, the closer the shell of an atom is to the nucleus, the lower the energy. So as you move away from the nucleus, the energy increases. So if we were to go back to, you said option what? You are not clear on option 3. So option 3 was saying that there are 3 2p orbitals in the second shell. 3 2p orbitals in the second shell. So if we come back here, where is the 3p? Oh, there are 3 2p orbitals. So we have 2p here. How many orbitals do we find in the 2p? 3 orbitals. There is this one, that one, and this one. So it is a true statement. Anyone who is behind? The one who asked a question, are you clear? Okay, so I think we can move. Question 2. So question 2 reads, the valence electrons of representative elements are, the valence electrons of representative elements are 1 in 1s orbitals only. So which of these statements is true about the representative elements which we call valence electrons of an atom? So one is saying they are in s orbitals only. 2 is saying they are located in the outermost orbitals. 3 is saying they are located closest to the nucleus. 4 is saying they are located in the outermost shell. Then 5 is saying they are located in the innermost occupied shell. So which of these statements is true about valence electrons of an atom? Our friend is saying option 2, which is saying they are located in the outermost orbital. This one. Anyone with a different view? Located in the outermost shell. So we have these two options, 2 and 4. Okay. So the correct answer here is yes. So in the outermost shell. I think there is not much to explain there. So the key here was valence electrons. Valence electrons, they are located in the outermost shell and not outermost orbital. That's why when you are answering biology questions, you have to analyze all the options. Don't jump into conclusion that the correct option before you finish reading all of them. You have to analyze. Because if you go for this option, it's disqualified because of that orbital. So you will get a negative 1. So make sure that you analyze all the options before you decide. Question 3. Question 3 reads, identify the statement that is not correct. So 1 is saying, for the hydrogen atom, the energy of the 2s orbital is lower than the 2p atomic orbital. So we're looking for the false statement, meaning that 4 of these are correct. So we're looking for which of these statement is false. 2 is saying, for a carbon atom, the energies of the 2s and the 2p atomic orbitals are different. We are just from discussing this from question 1. We said that the energy in the 2s is a bit lower than the energy in the 2p. Despite these orbitals being in the same energy level, 2p has got higher energy than 2s, so it's a true statement. 3 is saying, for an oxygen atom, the energy of the 1s atomic orbital is lower than that of the 2p orbital, which is also true. We are just from discussing this question. 1s has got lower energy as compared to 2p. Then 4 is saying, for any atom, the 3 2p atomic orbitals are degenerate. Then the last option, option 5, an atom with more than 2 electrons must use higher energy orbitals. So now tell me which of these statements is false. It's 1. Okay, that is what our friend thinks. What about others? What do we think? Okay, so the correct answer, the false statement here is option 1. For a hydrogen atom, the energy in the 2s orbital is lower than the 2p atomic orbital. So if you look at hydrogen atom, it only has got one shell, and that shell is the 2s, and hydrogen only has got 1 electron, so meaning that 1 electron is just in the 1s. It ends there. It doesn't go further into the 2s as well as the 2p. So in short, hydrogen doesn't have 2s or 2p, so it is a false statement. We move on to question 4. The lone pair of electrons in water are in the... Yes, please. Okay, so degenerate. I think in semester 2 you learn about the properties of the genetic code. So when we say degenerate, what we mean is that we have got 3 orbitals. The p sub orbital has got 3 orbitals. So these orbitals, any one of them can come first and any one of them can come last. They can interchange. There will be no any uh, significant changes that will be noticed. That's what it means. I don't know if you get that. Not really. So that is another property. What here I just mean, okay, yes. So if we were to denote this by x, y, z, what we mean is that this one can come first before this one can come at the end. There will be no significant changes that will be noticed. It's what, yeah, it's one of the properties you come across in semester 2 when you be looking at properties of genetic code, that is translation. So it's a true statement as well. Any other question? Okay, so we can move, I think. Have we answered question 4? Hi guys. Okay, so question 4 we didn't finish. Okay, so question 4 is saying the lone pair of electrons in water are in there. So here what you have to understand is what is the lone pair. Then also look, get to understand like what happens in the water molecule. How do atoms arrange? How are they arranged in that water molecule? So you know that in a water molecule you just have what? You have what? Oxygen and hydrogen atoms. So you have this H2O. What shape does the water molecule gives? Hmm? What do you call this shape? Guys, you have done this in chemistry. What? Yeah, but it has got its own special name in chemistry. So this shape we call it as a bent. I don't know if you have already covered that topic. It gives a bent shape. What's this angle? It's approximated to be between what and what? What degrees? This guy. Okay, so 104.5 degrees. This angle is estimated to be 104.5 degrees. These guys you have to know, they like this kind of question. Then, what partial charges do we find on hydrogen atom? These hydrogen atoms. Hmm? Positive. This one also positive. Yeah. Then on the oxygen, what charges do we have? Two partial negative charges, right? Delta 2 minus S, delta minus minus, like that. So I want you to understand this question 4. It's coming from this. So it's saying that one s orbit of hydrogen, the lone pair of electrons in a water molecule is in the 1s orbital of hydrogen atom. No, that is not true. Then 2, they are in the 1s orbit of oxygen. Is it true? I don't think, guys, you are getting this. Okay, let's do this. Okay. So, what is a lone pair? If we say a lone pair of electrons, what do we mean? Think what? Hello, are you still there? Can you get me? Okay. So what were we saying? What, okay. So now here we are dealing with a water molecule. So in a water molecule, I've got hydrogen. Hydrogen only has got one electron each. How many electrons does oxygen have? This one has got 8. The electronic configuration of oxygen is going to be what? 2, comma 6. Okay. So we are not interested in these electrons because these electrons, the electrons of oxygen, the first energy level, do not take part in the chemical reaction. The electrons that take part in the chemical reaction during the formation of water, it's those in the outermost shell, which we call valence electrons. So we have 6 of them. Now, of the 6 electrons, how many of them takes part during that bond formation with oxygen, with hydrogen, sorry? Only 2, right? So you have 2 are going to take part, will remain with 4, or the 6 will remain with 4. So these four, you know that an atomic orbital can only be filled up with 2 electrons like this. So meaning that the remaining 4 will be in 2 orbitals, 2 atomic orbitals, like this. So if we are to draw the energy level here for oxygen, we're going to find that we're going to have, this will be 1s, then we're going to have 2s and 2p. Then here we have, so these electrons do not take part in the chemical reaction. We are not interested in them. But these ones are the ones which takes part in the chemical reaction, or the remaining 6, these are going to take part in the bond formation between oxygen and hydrogen. Then we know that the p has got 3 atomic orbitals. How many electrons are we remaining with to fill these? So far we have used how many? Of the 8, we have used 2 here, and that 2 meaning that 4 have been used. We are remaining with 4 from 8. So you know the alpha-Bow principle in chemistry. So remaining with 4, you start by filling 1 here, another one there, another one here. We are remaining with 1 more, like this. Okay? So the question was, I think we can go back now. The lone pair of electrons in water are in there. So the lone pair, we have got 2 lone pairs here. The lone pairs come from the 4 electrons which remain. So 2 electrons, they form up 1 lone pair. Another 2 electrons will also form up what? 1 lone pair. So I've got 2 lone pairs in a water molecule. So it is this lone pair which gives us delta negative, and this one also delta negative. So now let's answer the question. The lone pair of electrons in water molecule are in there. 1 s orbit of hydrogen? No. 1 s orbit of oxygen? No. 1 s and 2p orbitals of oxygen. Then 4 is saying 2p orbitals of oxygen. 5 is saying 2s and 2p orbitals of oxygen. So where do we find the lone pairs in a water molecule? In which atomic orbital? So the lone pair are in the 2p orbital. So it's these ones here. These are the ones which will give us the lone pairs. So they are in the 2p orbital. So that's the answer. Anyone who is behind? Understood? Where is the question? The lone pair of electrons in the water are in the, yeah. So you still find it in the 2p atomic orbital. Any questions? Can move, right? Okay, so question 5. Question 5 reads, the phosphorus has an atomic number of 15. Therefore, its valence is So guys, be able to differentiate the difference between valence electrons and just a valence. The two are not the same. So we have got an atom of phosphorus here, which has got an atomic number of 15. So we are looking for its valence. So we have 1, 3, 5, 11, 15. So what is the valence of phosphorus? 5. Anyone with it? 3. So we have got two different. Okay, so let's see. So atomic number is 15. Electronic configuration is going to be 2, 8, what? 5. So the question is asking about what? The valence for phosphorus. So you know that if you are looking for the valence of an atom, if the number of electrons in the outermost shell exceeds 4, what do you do? If the number of electrons, yeah, you say 8 minus what? Minus that number. So here 5 goes beyond 4. So we can't say 5 is the valence of phosphorus, no. So it's going to be 8 minus 5. So the valence of phosphorus is going to be what? 3. So the answer here is 3. Now, I want you to, let me ask you this question. If this question was to be the same, let's say phosphorus has an atomic number of 15. What is its valence electrons? What was going to be the answer? If the question was asking about the valence electron. Yes. So the valence electron is going to be 5. Hope we are clear on that. So the correct answer here was 3, which is option 2. Move on to 6. An atom of... Yes, go ahead. Go. Okay, so the valence electron and just the valence of an atom. If they say the valence of an atom, you subtract, if it goes beyond 4, that's when you subtract from 8. You are looking for the valence. There's no valence of an atom which goes beyond 4. But if they say what is the valence electron, I think there's a question you're going to see. They asked about the valence electron. So the valence electron, you look at the valence electron, you look at the number of atoms or the number of electrons in the outermost shell. So just pick how many electrons do we have in the outermost shell? 5. That is going to be your valence electron number. Are we clear? Okay. 6. An atom of sodium with the atomic number of 11 and the mass number of 23 has dash protons, electrons, and neutrons. So we have got an atom of sodium with an atomic number of what? Is it a mass number? An atom of sodium, question 6. An atom of sodium with an atomic number of 11, so atomic number is 11, and a mass number of 23 has, so they want a number of protons, electrons, and neutrons. So let's answer it from here. So we have sodium. They are saying that the mass number is what? 23. And the atomic number is 11. So what is the number of protons? Number of protons? Yeah, so atomic number is the same as proton number. So this will be 11. What of electrons? 11. So proton number is equal to what? electron number in a neutral atom. Then neutrons, how many neutrons are we going to have in this atom? So you say mass number minus atomic number, so 23 minus 11. So we have a 12. So we should get 11, 11, 12. That's the answer. The order here, guys, is what matters. 11, 11, 12. So which one is that? Option 3. Yeah, simple as that. So we can move on to which other topic? Oh, question 7. The third shell of with 9 orbitals can hold up to dash electrons. The third shell with 9 orbitals can hold up to dash electrons. What's the answer, guys? So 2, 6, 8, 9. Okay. So yeah, so 18 is the answer. So what you know that each orbital can only occupy a maximum of 2 electrons. So if you have got 9 orbitals, you just multiply 9 multiplied by 2, so you get 18. Unless someone is behind. Question 8. The character of p orbitals, which determine the character of an atom, is the character of p orbitals, which determine the character of atom, is directional, non-directional, horizontal, vertical, diagonal. So what is the character of p orbitals? What's the character of p orbitals? And not really the shape, but what characteristics just. Okay, so I think maybe yeah, you're not. Okay, so what do we know about the p orbitals? What we know about the p orbitals is that it has got x, y, and z, right? So you're going to have, yeah, 3 dimensions. So you're going to have that will be y, then this will be x, then this will be z. So you have got what do you have there? So you have got px, py, as well as pz. So what does this tell us? Is directional. So that's the answer. So the p orbital is direction. It can give you direction. Like you are in the x-axis, you are in the y-axis, you are in the z-axis. That's direction. So the p orbital is direction. So the correct answer there was option 1. Yeah. Now I think enough of this topic. I want to us to look at, yes. Yeah. Okay, why it's direction is because if you look at the x or y plane, it's giving you direction. If you are in the y-axis, you know that that is what? Vertical. You are in the x-axis, that is horizontal. So there is direction. You can't go for option 4 that it's vertical, diagonal, or horizontal. In short, let's look at this, guys. Starting from option 3, horizontal, this is describing what? X-axis. Vertical, this is describing y-axis. Then diagonal, this is describing the z-axis. So what does that tell us? It gives us direction. In short, the p atomic orbital is the only atomic orbital which has got direction. So it's directional. That's why the correct answer is option 1. Direction. Are you clear? Alright. Question 9. An atom with 5 protons, 6 neutrons, and a charge of positive 3 has an atomic number of. So we're looking for the atomic number. So this atom has got 5 protons, then 6 neutrons, with a charge of 3 plus. What does it mean? If an atom is positive charge, what does it mean? It has gained or lost? Lost electrons, right? So what is going to be the atomic number of this atom? That's a question, I'm sure. Yeah. So what's the atomic number of this atom? Y5? Y5? Hmm? Yeah, that's true. So atomic number is equivalent to what? Proton number. So this loss of electrons has no effect on the atomic number. So the confusing question that you may come, okay, I think enough of this topic. Let me see if I can grab another. Okay, so let's move on to question 16. Water and its properties. There are a lot of questions in exam as well as test from this topic, water and its properties. So I'll tackle a few, then we'll move. So question 16 reads, water molecules are held together by dash in a water body. So here I think we're interested in the bonds. What bonds hold water molecules together in a water body? So we have covalent bond, hydrogen bond, hydrostatic forces, Van der Waals, and hydrophobic interactions. What bonds hydrogen bond. Okay, I like that. Then what bonds exist within a water molecule? Yeah. Yes. So we have answered. So the correct answer is 2. So hydrogen bonds only exist between water molecules. When one water molecule is being linked to another water molecule, the bond that you are going to find there are what? Hydrogen bonds. But if you just have one water molecule which consists of 2 hydrogen atoms and oxygen, the bond that you are going to find there are what? Covalent bond. So between covalent and hydrogen bonds as well, they will ask you which one of these is stronger than the other. Yeah, covalent bond. Yeah. That's why when you warm water, the bonds that break is hydrogen bond and not covalent bond. Question 17 is saying identify the false statement. One is reads, water adheres to the surface of its container. Is that a true statement or false? So we're looking for a false statement. Water adheres to the surface of its container. True or false? True. 2 reads, water conducts electricity. True or false? True. 3 reads, water can dissolve proteins. True or false? 4 reads, water sticks to a grass because of coercive forces. True or false? False. Then let me finish with 5. 5 reads, water moves along blood vessels because of coercive forces. Coercive and adhesive forces. So which option is false? 4. Yeah. So what forces makes water to stick to a glass? Yeah, so different forces adhesion. Yeah. 18. Water bodies in a lake and oceans have constant surface temperature because Water bodies in the lake and oceans have constant surface temperature because 1. Water freezes at 4 degrees Celsius. Is that the reason why water bodies have got constant temperature? It's not. Then 2 is saying because of hydrophobic interactions between water molecules. Is that a true statement or false? Then because ionic bonds are formed between oxygen and hydrogen. False, right? We don't have ionic bonds in water molecules. Do we have? Oh no, where am I? Okay, so 3. Because water shrinks for every degree rise in temperature. Then 4 is saying because water has high specific heat capacity. 5 is saying because water has a high latent heat capacity. So why is the temperature of ocean or lakes nearly constant? What's the answer? Okay, heat capacity. Yeah, so that's true. So, for you to change the temperature of water, you need a lot of energy. So, because you need a lot of energy, you find that um, in a lake or ocean, you know that the only source of heat which is there is sunlight. So, for you to change that temperature, meaning that you need a lot of heat, which is not enough to reach maybe the up to the end point of that lake or water. So you find that it's very hard to change the temperature of what? Of water. So that is what we call high specific heat capacity. Then what about this high latent heat capacity? What is it all about? Yeah. So high latent heat capacity. So the amount of energy which you need to change water from liquid to gas. That is a simple explanation for mm, high latent heat capacity. Latent heat capacity. So the answer here, guys, was this same one, option 4. High specific heat capacity. It's not just any other temperature that can change the what? The temperature of water. You need a lot of energy. Okay, so 19 reads, when oxygen combines with hydrogen to form water, one is saying there are two lone pairs of unshared electrons. 2 is saying there is one lone pair of unshared electrons. 3 says the ionic bonds are formed between oxygen and hydrogen. And 4 is saying develops a positive charge. 5 is saying covalent bonds are formed between hydrogen atoms. So which of these statements is true about the formation of water molecule and the interaction between oxygen and hydrogen? Mm? There is only one pair of unshared electrons. Others, what I say? Hmm? Hmm? Others, what I say? Do you agree with him? Okay, so I like that, guys. Okay, so the correct answer here is one. This is why previously I asked you to say what does a lone pair mean. If we say a lone pair, here we mean just two electrons. Two electrons is one lone pair. So how many unshared electrons do you have in oxygen in a water molecule? You have got four electrons, right? These do not take part in bond formation. So these are going to form how many lone pairs? They will form two lone pairs. You have, that's why you have got the delta negative and the delta negative. Here you have got two electrons. Here you also have got two electrons. So this is a lone pair. This is also a lone pair. So together they form how many? Two lone pairs. So when you hear a lone pair, it's two electrons. So if I say three lone pairs, meaning that you have got six electrons. Is that clear? Yeah, so the correct answer here is option 1. Which another topic can I jump? Which topic? Think that will be the last one. So this is, I think this paper, guys, will help you. You should revise as you go write your test. Revise. It has got a lot of questions. Will help you to understand the topics that you have covered, as well as it will help you also prepare for the test. Then there are also solutions for. Yeah, I think okay, we're going to share in the group. There are solutions for this same paper, so you can access them by contacting our admins. The solutions are there, well explained. So maybe let's look at one or two questions on carbohydrates. You have covered carbohydrates, right? Okay. So let's look at that. So carbohydrates. Carbohydrates, we have question question 21. So let's start from question 20. The bonds that are broken when water vaporizes are dash bonds. I explained this one. Hydrogen bond. Yeah. 21. Sucrose is a non-dash reducing sugar. Is a non-reducing sugar because the dash of its fructose ring and the dash of its glucose ring are not free. So sucrose is a non-reducing sugar because dash of its fructose ring. So we're looking at the number of carbon which is not free in a fructose ring, and also the number of carbon atom in a glucose molecule which is also not free, to make sucrose not to be a reducing sugar. So it's between which carbon and which one. For fructose, let's start with the fructose. Carbon what? Fructose. Yeah, fructose is carbon 2. Then glucose is carbon what? Carbon 1. So C2 and C1. That is option what? Option 2. So now you have to understand these bonds. So during the formation of sucrose, what happens is that you have fructose, which is going to give out the OH group at carbon 2. Then you also have got glucose, which is going to give out the hydrogen at carbon what? Carbon 1. So for this bond to be possible, what happens to fructose? What should fructose do for this bond to be formed? Yes, that, apart from that. I think there's even a question. As you go down in this paper, you're going to find that question. So what happens is that fructose has to turn how many degrees? For this bond to be possible, fructose should turn how many degrees for it to react with the glucose? You should check out. Shehat has given you those notes. So fructose has to turn 180 degrees for it to form this bond with glucose. You should check out why that is so. Yeah. So there is a question on that as well. You find it here in the same paper. Question 20 what? 22. So I've got this carbohydrate here. The question is identify the asymmetric carbon atoms in the molecule below. So I've got this molecule, so we have to identify which carbons are asymmetric. So this is carbon 1, 2, 3, 3 and 4, 5. 3, this is 4 and 5. So which carbon is asymmetric? First we have to understand what is asymmetric carbon. What is an asymmetric carbon? Okay, let me use a different term. Have you heard of a chiral atom or chiral carbon? I've never. Okay, so a chiral atom or chiral carbon is an atom that is attached to 4 different molecules. Let's say if I have carbon there, then this carbon is linked to, let's say, hydrogen. Then this side is linked to oxygen or hydroxyl. Then this side is linked to, let me say, another carbon. This side is linked to, let me say, nitrogen. So this carbon at the center is what we call asymmetric carbon or a chiral carbon. Chiral as in C-H-I-R-A-L. Chiral atom or chiral carbon. So it has to be linked to 4 different functional groups or atoms. Failure to which, let's say, if here we had another hydrogen, we can't call this one as a chiral carbon because this one and that one, they are the same. So all the 4 have to be different from each other. That's when a particular atom is going to qualify to be called an asymmetric carbon or a chiral carbon. So that is what this question is asking us. So which of these carbon in this carbohydrate molecule open chain structure is an asymmetric carbon? So from the options here, you can tell that you have 2 carbons at least which are chiral carbon, because we don't have an option which has just 1 carbon. Okay, so without wasting your time, carbon 2 is a chiral carbon. If you look at carbon 2, it's linked to hydrogen this side, hydroxyl group this side, this whole group this here, and also that one. these all four are different from each other. So carbon 2 is a chiral carbon. So we have 2. What else? What else? Is carbon 3 a chiral carbon? No, right? Carbon 3. So carbon 3 is linked to, we have hydrogen this side, hydroxyl group this side, this group, as well as this one. Yeah, so carbon 3 as well is also a chiral carbon. Let's check carbon 4. So carbon 4 has got hydrogen here and hydrogen there, so it is not. The last carbon has got hydrogen, hydrogen is also not. So the correct answers are, it should be 2 and 3. Do we have that option? 2 and 3. So option 5. Anyone who is not clear on this? Any questions? Let me get the last. Okay. So the question that I was telling you is this one. Check question 28. Have you seen? Beta fructose must 10 dash degrees in order to make the 1 to 2 glycosidic bond in the sucrose molecule. So what's the answer? Yeah. 27. We have got this chemical formula C3H8O3 is dash, fatty acid, a lipid, an alcohol, steroid, or trials. 27. What's the answer? It's what? Trials, yes. Yes, yes. So when you see OSE, it simply tells you that that particular molecule is a sugar. Then tri simply means 3 carbons. So that's what we can see there. Let me get the last question. Then we call it a day. Madrid fans, are you here? I doubt. Okay, let me get question 29. 29 and 30, then we call it a night. Identify the statement or statements that is or are a function or functions of carbohydrate. So which of these is a function of carbohydrate or are functions of carbohydrates? So we have got structural support. True or false? It's true. Immediate energy provision. True or false? Then 3, energy storage. Formation of nucleic acids. Formation of nucleic acids. So I think there's a debate there. Nucleic acid. False. Then all the above are correct. So what's the answer? So if you are saying 5, you told me that 4 is false. Mm. Okay, so guys, simple stuffs here that nucleic acids. Nucleic acid, we're talking about RNA and what? DNA. So what are the monomers of these nucleic acids? What are the monomers of nucleic acids? Oh, you haven't done this topic? Oh, yeah, I get. Okay. Then I think let me not confuse it. Okay. So here, since I've already started, the monomers of these are nucleotide. So nucleotide is made up of a sugar, um, a sugar, a nitrogenous base and a phosphate group. So this sugar is a pentose sugar. So it's one, when we look at the carbohydrates as where is that? Formation of nucleic acids. So we can see that indeed carbohydrates also here helps us to form what? Nucleic acids. They are part of nucleic acid. So it's a true statement. So all the above statements are correct is the correct answer to this question. So question 5. The last question, guys, is question 30. The helical structure of amylase is stabilized by the helical structure. This is protein, right? No. Carbohydrates. So this is starch, right? So what bonds makes it possible for amylase to have helical structure? Hydrogen bonds. Anyone? I draw it. Hydrophobic and Van der Waals. So hydrophobic, you have to deal with something being not interactive with water. So water has to be involved always. Whereas if you talk of Van der Waals, Van der Waals does not restrict to anything. They are just very weak forces. So something that cannot interact with water, that is hydrophobic. Whereas Van der Waals have nothing to do with water. But Van der Waals are much weaker as compared to hydrophobic interactions. Okay, guys, so if I start explaining, we can Coca-Cola here. So the correct answer here is option. Yeah. So we have this, guys. We have both covalent bonds as well as hydrogen bonds. So the correct answer is option 5. So the helical structure of amylose is stabilized by both covalent bonds as well as hydrogen bonds. Yeah. So let's end here, guys. We'll meet again next week, I think, this same time, this same day, because we'll be meeting once a week. So if you want to continue being with us, just register with Transcendent then. No. That is direct -1. So you'll not be given half or whatever. That's -1. Unless if covalent bond was not there. The correct answer was going to be hydrogen bond. So if there's an option which combines two which are true, you go for that option that combines.